Okay, so when we watch that video, if it makes us feel anxious, it physically is changing how our body works. And it's acting through a part of our nervous system called the autonomic nervous system. So this is the part of your nervous system that operates your body without you consciously telling yourself, I need to breathe now. My heart needs to beat now. And to move that food down lower in my intestines. We don't think about doing that, but it happens. And our nervous system is controlling it, but we're not consciously making it happen. It's sort of going on autopilot somewhat. So this is a continuation of nervous system from AMP1, just a little bit in AMP2. And your autonomic nervous system controls those body activities that we don't have to think about. So if you've got notes that are already filled in, you can just underline this stuff. It controls breathing, your heart rate, your digestion, and one that we don't often think about, glands all over your body secreting stuff. Sweat glands, salivary glands, digestive glands like the pancreas. All of those are controlled by the autonomic part of your nervous system without you thinking about it. It'll happen. That's a good thing. We have enough to think about without worrying about that part. So the autonomic nervous system, it's also called ANS. I'll abbreviate it that way. And your ANS has two divisions. So kind of like sensory versus motor. Autonomic nervous system has a branch called the Sympathetic Division, and there's a branch called the Parasympathetic Division. And I want you to, forever, after this, remember that the Sympathetic Division goes with fight or flight response. You heard of that, fight or flight response? Do you have it right now? I hope not. I hope you're kind of in parasympathetic right now. But generally, if you've got notes, you all do today, right up here, generally, for the most part, generally, the sympathetic division of your autonomic nervous system will speed up certain body processes and get you ready for action. Get you ready to do something, like right now. So when I watch the train and it knocks the guy's shoe off, I can feel that my heart starts beating faster, and I feel like just kind of uncomfortable. And if you were to put, and you measured my breathing would change. I would actually have more blood flow to my muscles. For what? So I could do what? Help him. Is that weird? Do something. I sense something that's a problem. My body gets ready to do something. So if you have test anxiety and you come in the room and plop, there is the test, and you start feeling that way, your body is getting you ready to do something that is the wrong thing. It's getting you ready to like run around, jump over a ditch, wrestle a lion, things that people used to be able to do and need to do in an emergency, when what you need to do is calm down and think. It's hard. That's sympathetic nervous system, that's fight or flight. The other division kind of reverses those effects. So right here, generally the parasympathetic division slows down those responses. It's not trying to make you get ready for action. It's trying to get you in a state where you can just do your daily housekeeping stuff. Like rest. You can't rest when you're freaked out, anxious, sympathetic nervous system activation. You also cannot digest when you're in fight or flight response. If you're a stress pooper, that's related to this. Like, I don't have time to digest the food right now, let's just get it out. That's where stress pooping comes from. If you're really going to rest and digest, you need parasympathetic nervous system to slow down certain body processes and allow resting and digesting. So we're going to go through some of those specific responses now. Okay. I want to say a little bit, since this is the first day, about what you do with picture slides like this. Our textbook frequently has more detail on a picture than you need. When I put a picture on a slide, it's because I need you to know something about the picture, but not necessarily everything. In this case, it's a visual depiction of what I'm talking about on the left. So when you see a picture like this, I will tell you either in lecture or in lab what are the important parts to know. For this picture, we're going to be looking at this side, and it's probably easier to see on your handout than here. This side is showing how you have nerves coming out of the spinal cord, controlling motor function, and also controlling, also bringing in information from sensory glands, or sensory neurons. That's old news. We're going to look at this side. So this is showing that also your autonomic nervous system is sending signals out to control muscle or glands that allow those responses. This is a complicated picture, but it's the same concept. You have some sensory neurons that are sending signals from your guts, so to speak. You have other neurons coming out that control the action of your guts, so to speak. Guts being all your internal organs. So these nervous system pathways, they go through the spinal cord. They are passing through the spinal cord on their way to these organs, and they do something called innervate. That word innervate, I-N-N-E-R-V-A-T-E. Anything that I write over here should also be written on your notes. Oh yeah, cloth erasers. White at the beginning of the year. So I would like you to know this word and one other. Innervate, spelled this way, means to control something via neurons. It's a very useful word. Innervate. There's a different word called innervate. It's spelled with an E. That generally means to disrupt a function. Innervate. But we're talking about innervate. So smooth muscle, cardiac muscle, glands, those components of your internal body systems are innervated by neurons that come out of the central nervous system. They're going to be internal organs. What I want to do next is show, it's easier on your page than here to see this. This is a picture of the sympathetic division, and this is overwhelming. So again, what do you do with an overwhelming picture about like this? What's this? There's the brain. What's this? There's a spinal cord. There's stuff coming out. Those are neurons sending signals from these particular level of the spinal cord out to this set of organs. So what this picture tells you is that this set of organs are in some way controlled by the sympathetic division of the autonomic nervous system. And it's a lot. A lot. That's generally what it's telling you. I don't need you to know the things in between for this class, but these organs can have their function changed in some way by the sympathetic nervous system activating them. And it's a lot. We're going to talk about some highlights of how some of these are changed by the sympathetic division. So this slide goes with the previous. We're still talking about specific actions of the sympathetic division. And what I want you to do is talk to your neighbor, discuss what do you think the sympathetic division of the autonomic nervous system would do to these factors. 2 minutes. Got some ideas? I'm going to call on some people. Joseph, what would the sympathetic division do to heart rate? It increases it. I'm going to write over here, but you would just, on your page, write over here. So heart rate increases, your pulse would go up, your heart would beat more often. That one's pretty easy to understand. What about breathing, Cass? What do you put for that? How do you measure breathing? Yes. Breathing is a little bit more complicated than heart beating or not. So heart rate, you have a speed, it goes faster or slower. Breathing, it's a little more complicated than saying it increases. So you have an increased rate, you'll breathe more often, but you actually breathe more shallowly as well. So it increases the rate, but you are taking shallow breaths generally, which is why when you're anxious, you can use breathing exercises to take deep breaths, and you can consciously change what your body is doing. We'll talk about that more in a minute. Anissa, draw back because I already know your name. What about blood vessels?
My blood will be pumped through the blood vessels.
You would have more blood pumped through because your heart is beating more often. More through. What would happen to the diameter of your blood vessels? What'd you say? So you get more blood moving through, but your blood vessels actually constrict. That one's not as obvious. If you just think about what you feel like when your sympathetic nervous system activation, your blood vessels constrict and your heart beats faster. What happens to your blood pressure? It goes up. That makes sense. If your heart's beating more often, if your blood vessels constrict, your blood pressure goes up. So you can just draw an up arrow, say that it rises. Your blood pressure goes up. If you've heard that people who are really stressed all the time have high blood pressure, that is true, and this is why. If you stay in sympathetic activation a long time, your blood pressure will go up. What about digestion? George?
It stops.
Stops, slows down at least. It might stop. It definitely slows down. So I would write slow down on there. You definitely will not be getting maximum nutrition out of your food. slows down. So those general things, that's not all that the sympathetic nervous system actually does, but those are the highlights. So keep in mind that there are also effects on all of these other organs that we haven't covered and that may be important for your specific field, but this is an overview. We're going to do the same thing. Oh, I know what I wanted you to write here. Right here, notice that these effects are coming from thoracic and lumbar regions of the spinal cord. So that was one of the points of this picture, is that these responses are mediated out of your lower spine, of speeding up your heart rate, changing your breathing, and so on. Okay, now let's look at the parasympathetic division. Here's another picture with the brain at the top, spinal cord, and a lot of organs. But notice where the neurons are coming out to innervate parasympathetic responses. So they're either coming out very high from the brainstem, or some of them super low down at the sacrum, not in between. So there's a spatial organization there. Parasympathetic responses are innervated out of the brainstem and out of the sacral region. Still going to the same organs because they're reversing the effects. You can speed things up, you can slow things down. So what would parasympathetic effects do to these factors? This one we won't do a talk to your neighbor activity. What would happen to heart rate? Just slow down. What'd you say, lowers? Yeah, slows down, lowers. Your breathing is less frequent but deeper. Less frequent but deeper. It's important to know both those factors. Like saying that breathing decreases is incomplete knowledge. What would happen to blood vessels? You know, what's it called? Dilation. Let's add that in. In this response, blood vessels dilate or expand. Or we can also call that vasodilation. We'll see that word later in the semester. What about blood pressure? Would decrease because your heart is slowing down. Your blood vessels expand. You don't magically have more blood. You've got the same amount of blood. It pushes less hard against the walls. If that was too fast, we're going to go over blood pressure in like a whole section later. But just note here, your blood pressure will go down under parasympathetic control. Digestion increases generally, or becomes more effective. I want to add in just a few more one more line on each of these specific actions, which is about glands, generally. Glands, I say that so redneck. Let's talk about glands, or glandular secretion. Glandular secretion is mostly decreased in sympathetic activation. This is why you get dry mouth, and partly why your digestion doesn't work well. You're not secreting digestive enzymes. But there's one gland that secretes more. What would that be? Yes. Yes, and sweat. You're going a little bit more than further deeper than I was going to. Sweat glands. So, except adrenals and sweat. Every year on the first day of class, I wonder how many more years I'll be in sympathetic nervous system activation on the first day of class. Maybe always. Maybe always. It's not as bad as it used to be. So in parasympathetic activation, most of the glands, except for those two, would secrete more. So your tear glands, your digestive glands, and the pancreas, all kinds of glands all over your body, except for sweat and adrenals. Saliva is the other one. Why would you need more saliva if you're going to digest? It's helpful. Mostly so that you can swallow food after. That's the main reason you need it. So your add on to your list glandular secretions as well. And then we have one more page, and this will be where we end. This is a review. Autonomic nervous system is controlled by the brain and spinal cord. And your brain stem is very important in allowing your heart, lungs, and blood vessel constriction and dilation to work at all. You need the brain stem for that. Things like being thirsty, temperature, water, and electrolyte balance, that's hypothalamus. Those things can be adjusted. Draw out here on the side of your notes. These factors can be adjusted by the autonomic nervous system, up or down, faster or slower. But they are majorly controlled by the brainstem and the hypothalamus. When you see something and it scares you, that's acting through the limbic system. Or if you smell something and it scares you. What's a scary smell? Smoke, yeah. I smelled a scary smell recently, and now I can't remember what it was. And it would only be scary because I remember at that time in my life I was scared when I smelled it. Oh, I know, like acne wash. When you're older, if you had bad acne when you're young and you go back and smell that, it will make you feel bad and awful all over again because you associate the smell with stress. And it can actually make your body go into stress patterns. PTSD somewhat has that effect as well. You can also, if you've heard of biofeedback or positive thinking, deep breathing, you can do things to suppress your sympathetic nervous system and consciously change your body function as well. It's not that this is on autopilot. And then the final thing I wanted to say is that this is something that you know before you technically learn about it, that people can be brain dead, but they still do heart, breathing, they have blood pressure, because they have brainstem and they have hypothalamus function. Those continue even if they have a spinal cord injury up high. That continues. It's just that they don't have sympathetic nervous system control. Whoops, I went the wrong way. It happens a lot. They don't have sympathetic nervous system control from this point down, but if you've got brainstem and medulla, you can still operate your heart. You can still operate breathing, even if you're unconscious. Does that sort of make sense what I'm saying? That's a super brief overview of autonomic nervous system. We'll stop for today. For Friday, you need to do the assigned skimming, reading, looking for what's next? Blood? Blood.